Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on digital communication. This video, I'm going to explain the different types of transmission impairment. For example, when we actually transmit a signal, we want our recipient to receive the exact signal that we actually want to transmit. However, in a practical world, this is almost not possible. This is because the signal may somehow subject to impairment. For example, the signal can have some form of attenuation. They probably will be incur more noise. Some form of distortion actually make our signal unable to recognize by the receiver anymore. Definitely, when you actually send a signal over a distance, there will be some form of delay. And last but not least, jitter. So basically all these are the possible effect of transmission impairment. Guys, this is my email. If you have any question regards on this discussion, please drop me an email. Or if not, I actually prefer you guys to ask your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. For those who are new to this channel, and if you want to encourage me, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Transmission impairment. Let me explain why we have this transmission impairment. For example, you can see from here, I want to send a signal from the transmitter to the receiver. Let's say the transmitter and receiver is basically linked by this coaxial cable. So what happened here is basically the signal will degrade when they actually travel through this imperfect transmission medium. For example, for this case, the transmission medium will be the coaxial cable. There will be some form of signal degradation when they actually propagate along the coaxial cable. So basically this phenomenon is actually known as transmission impairment. For example, one of the clear-cut imperfect transmission medium will be the resistor. You know that although so-called copper is a good conductor of electrical signal, however, definitely there will be some form of loss which is represented by resistor. So therefore, we are going to subject to have some form of attenuation. So basically the resistor add on the so-called link between the transmitter and receiver. So therefore, we have some form of signal attenuation. You can also imagine noise can be added to the signal. For example, if let's say we have a wire that is basically introduced crosstalk, the noise can be coupled over from one wire to another wire, and therefore noise will be introduced to the overall propagation signal from the transmitter to the receiver. Next will be distortion, and latency and delay. As I mentioned earlier on, when there is a distance between the transmitter and receiver, you definitely will have some form of delay because signal actually need time to propagate from one place to another place. The longer the distance, the longer delay you're going to subject have. Last but not least, on jitter. So basically the signal actually received different from the one that is actually transmit. As I mentioned just now also, when we want to transmit the signal, we want the receiver to receive the exact signal that we actually want to transmit. However, this is not possible due to this fine transmission impairment. So once we have some discrepancy on the receiver signal, this actually will cause the reduction of the quality, or in digital form, there will be even some form of bit error, which means that instead of 0, I receive 1, which is totally wrong. So basically this is on the transmission impairment. Let's come to the first transmission impairment, which is attenuation. So attenuation is actually a reduction in a signal strength as it travels through a medium. So this is often described as a gradual loss of energy. For example, can be the outcome of the resistor in a wire. Let's take a look on this diagram in order to understand what attenuation is. So basically from here, this is basically the transmission point. So you can imagine that the signal actually propagate along the transmission medium. So now after some time, it actually reached the point 2. From here, you can clearly see that there is a change, okay, in terms of the signal from the original transmit signal until where it is at point 2. You can see that attenuation actually happened. What is exactly attenuation? You can see that the signal frequency and phase remain intact. However, the amplitude actually becomes smaller. This is a very simple definition of attenuation. Attenuation only affect the amplitude. Okay, so basically from here you can see that attenuation is basically depend on distance. Okay, you can imagine that the longer the distance, the more loss that I'm going to subject with, and therefore I'm going to have tolerate more attenuation effect. And then next will be the types of medium. Okay, because different types of medium, I'm going to subject to have different loss, which is different resistor value. And then we may have some environment factor, for example, some interference or even physical obstruction. Okay, so if the signal weaken beyond a certain threshold, okay, which means that they become smaller and smaller until that a sense that okay, basically are below the threshold, then it becomes very hard for us to distinguish, let's say for digital communication, whether it is a 0 or 1, it can be a very big challenge. Okay, so this potential led to data loss. However, in this diagram, you can see that amplifier can be easily used to boost the signal strength again. Okay, so basically the amplifier will only boost up the amplitude. Okay, so basically amplifier can easily so-called solve the problem of attenuation by boost up the signal strength, okay, to counter this effect. One of the clear example will be a long distance call. Okay, imagine in the old days we are linked by copper wires. Definitely, when the signal propagate along the copper wire, attenuation will happen. Okay, so this make the so-called the sound become faint or even inaudible, okay, which means that you cannot even hear the sound anymore. So the key solution is to have amplifier, as you can see from here, or even repeater, okay, because amplifier can easily boost up the amplitude, okay, which meet the signal back to the original so-called size in terms of the amplitude. Okay, so basically this is the first transmission impairment, attenuation. Next will be noise. Okay, so in fact, noise is everywhere. For example, now when I actually talk, you probably can hear my background noise. Okay, so basically that is also classified as noise. In short, noise is actually referred to unwanted electrical interference that may disrupt a transmit signal. It can originate from the source. Okay, like I mentioned earlier on, when I talk the background noise is basically from the source, okay, such as electromagnetic interference, crosstalk between cables, and internal thermal noise from electronics component. Okay, so by blending with the original signal, noise reduce the clarity, distort the data, and increase the error rate, which may require retransmission. From this diagram here, you can see that if let's say with the signal only, you can see that probably is a perfect sine curve. However, once noise add onto the analog signal, you can see that it is not longer a perfect sine curve anymore. It basically has some form of so-called noise that is actually added onto the original signal. As you can see that this is how does the noise actually look at. This is for digital signal. Okay, basically with the signal plus the noise. Okay, ideally with a perfect signal, we simply so-called a solid line. Okay, with a 0 or 1. Okay, but once incurred noise, you can see that noise actually affect the integrity of the signal. So one of the simple example resolve all this noise, okay, is basically having the improve the signal to noise ratio. How can we actually improve the signal to noise ratio? We can boost up the signal strength, or in fact, we can use shielded cable to prevent coupling. Okay, so all this in fact can mitigate all this effect. So an example is actually static in a radio broadcast that is actually caused by nearby electrical equipment. Okay, so basically this is the second transmission impairment, noise. Next will be distortion. Okay, so in fact, distortion is the most severe one. Okay, so earlier on you saw attenuation. And attenuation simply reduce the signal amplitude. Next will be noise. You can see that noise typically will add onto the amplitude of the signal. However, for distortion, it can drastically change the shape. While for attenuation and noise, typically the shape and the size remain almost intact. However, for distortion, it's a complete change in terms of the signal shape during the transmission. When it can be possible occur, okay, it can actually occur when different frequency component actually travel at different speed. Let's take a look on this diagram in order to understand better. Okay, for example, let's say, okay, I'm going to generate a square wave, which actually make up of many different kinds of sine wave. They add up to become a square wave, for example, for this case here. However, okay, because of the different speed, okay, for different frequency, okay, this actually cause some form of distortion of the original signal. So therefore, you can see that the composite signal actually received, they are actually totally different as compared to the original signal that I actually want to send. You can see that some form of distortion. Okay, so basically this is for the distortion. Okay, so some simple example is, for example, in a video call, okay, the distortion can actually cause the image totally cannot be recognized, or there is some form of delay in terms of the audio. So one of the simple example will be using the equalizer and the phase correction filter. Okay, so basically this is for the distortion. Latency and delay actually refer to the time that it actually require for the signal to travel from the sender to the receiver. Okay, based on the distance, the longer the distance, the longer delay that you're going to anticipate. Okay, so basically you can't remove away the delay. Definitely you will have some form of delay because the signal actually require time to propagate from the transmitter to the receiver. And also sometimes, okay, the latency can be due to the network congestion. Okay, because there is some form of congestion, it takes a longer time for the signal to arrive at the receiver. This can be also an issue. And also we have some form of processing delay, okay, because some data require us to process, and therefore, okay, we may have some form of delay. Okay, so all these actually relate to the latency and delay. One of the very simple example, a delay, okay, for example, in a video conference, okay, where participants' voice overlap or correspond are out of sync due to high latency. Okay, but nowadays I believe we don't have this kind of issue. In the early days, okay, where we can have some conference that we can have some form of high latency, and therefore you can see that some voice actually overlap. The picture is also not clear. Okay, but like I mentioned earlier on, okay, so this form of delay is actually totally removed, okay, because of the advancement of technology. Last but not least, jitter. Okay, so what is actually jitter? Actually, jitter actually describe the variation in packet arrive time. Okay, basically for digital signal, okay, all the packet can arrive at different route. Okay, so but certain route may have a favorable so-called time in terms of the delay. However, this jitter, in short, they actually describe the variation, okay, in terms of the packet that actually arrive in the network. Okay, so this again can be caused by network congestion, poor routing, and synchronization issue. The jitter can have a severe impact for those that are having so-called live, for example, voice over IP and video streaming. Okay, so one simple example will be the voice over the IP call. Okay, the voice become very choppy and become very like a robot talking, okay, due to the varying packet arrive time caused by the jitter effect. Last but not least, okay, so beside we talk about the transmission impairment, we also have the transmission impairment for wireless communication. Okay, so basically these are totally different from what I described earlier on, but just want to give you some idea. Okay, you probably heard about multi-path propagation. Okay, because the signal may not travel just the same path. Signal can travel many different paths. This is what we call the multi-path propagation. Okay, for example, the signal may reflect off the building or any obstacle that are huge in size. Okay, because of the reflection. Okay, this actually cause some form of interference and also distortion to the signal that we actually intend to receive. Next will be on the signal fading. Okay, due to environment change, let's say raining time. Okay, I'm not sure whether you have this kind of experience. Okay, your mobile phone typically will become weaker. okay, because of the environment change, your signal, okay, let's say that they actually scatter around. Some of the signal may scatter around. This actually cause some signal degradation. Okay, so basically this can weaken the signal, and in fact they can impact the data transmission. Next, also based on the interference from other device. Okay, so not only you are the one who transmit over the air, a lot of device also transmit over the air. Basically, all this can be a form of so-called interference. So in order to address this issue, okay, nowadays we have new types of technology like MIMO, okay, which is multiple input, multiple output, and even beamforming, okay, which means that this beam actually just want to serve you only, and they basically have a very concentrated beam that is actually direct to you. So basically with this, you can imagine that the interference will be lesser because this beam is basically just served directly to you. Okay, so basically this is what I have for transmission impairment, okay, for digital communication. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.